Good afternoon, everyone. The handouts were updated, okay? All the handouts were updated. You can refer to the handouts also. And if anyone is having any queries about the previous sessions, you may drop it in the Q&A. And in the meantime, we'll just wait for another 5 more minutes. Let everyone join, okay? Thank you. Yeah, good afternoon, guys. Okay, I hope everyone is here. So everyone were able to see the handouts, right? The handouts have been updated. Still, anyone not able to see the handouts? Sorry. It's having the drive link, right? The drive link and also the Telegram link. Able to see the notebooks and also all the implementation part, right? Okay. So I see no one is having any doubts. Fine, we'll just proceed. Okay. So everyone understood GANs and VAs, right? Any doubts in that, anyone? GANs and VA architecture. If anyone is having any doubt, let me know. Okay, fine. And also one more thing, I'll just upload this GANs notebook. Just upload the GANs notebook over here in the notebooks, and we'll try to implement that. Okay, I'll just create the folder. Okay, and the folder is available now. I'll just copy that, and I'll be just uploading that so that you just need to download that and edit it in the collab. Okay, that is what you need to do. All the code is ready. We need to understand each and every line, and we need to implement that code. Okay. So once confirm me, everyone are able to see the GANs notebook. Not able to see the notebook. The notebook has been updated in the drive. Okay, I have just now uploaded. You will be able to see the notebook. Let me just check. Yeah, the same only. Let me just share the drive link once again. Yeah, everyone is having access. I'll share it in the chat once again. Yeah, this is the drive link. Okay. The drive link I have updated. So please click on that link, go to the notebooks, and under the notebooks, you'll be able to see each and every notebook which we have implemented in the same drive link where I have uploaded the text to text and text to image notebooks. Okay, that whole complete file I have updated, right? In the same drive link only we will be having. I hope you are able to see. Everyone able to see. Once you people confirm me, yeah, it is accessible, right? So Everyone open that notebook in the collab. We'll try to understand each and every cell. Okay, we'll try to understand each and every cell, and then we'll implement that notebook. Okay, it is regarding the GANs. Okay, just give me a minute. I'll just open the notebook in collab and I'll share the screen. So you want me to send again the drive link you're saying? If the notebook is accessible, then it's fine, okay? And I hope you are able to see the screen also, everyone. Just confirm if anyone is not able to see the screen or else any issue, let me know. Okay. So we'll begin with the explanation part, okay? We'll begin in that case. Shall we begin, guys, or else anyone having any doubts? Okay, fine. Just a moment. We'll just start, okay? Okay. So initially, what are we doing over here? We are initially loading the libraries or importing the libraries. Correct. What are all the libraries required over here? What are all the libraries required over here? What do we require here? We require NumPy, we require TensorFlow, we require in the TensorFlow again we are having Keras, and in the Keras also we are having layers, okay? And in the layers we are having dense, flatten, reshape, leaky relu. Remember this dense layer, flatten layer, and leaky relu. And again from the TensorFlow Keras models, we are having sequential, matplotlib, which is used for plotting the graph, and OS. So what each and every library is, see, as we all know, NumPy. NumPy is used for doing the mainly numerical operations and array handling, right? numerical operations like array handling. Correct. So this is one main feature of this NumPy. And what does TensorFlow do? It will load the TensorFlows, right? It will load the tensors for the deep learning. When we are working on any deep learning architecture, when we are working on any image data, then we will be working with the tensors only. Okay, with the tensors. And what does the dense layer, flatten layer, reshape layer do? Dense layer is nothing but a fully connected layer. We all know that, right? See, dense is nothing but dense layer is nothing but a fully connected layer. Okay, is a fully connected layer, and also we are having this flatten, right? What exactly is flatten? Flatten is nothing but remember when we are discussing about the GANs and VAs reshaping, whenever we are having a 28 cross 28 cross 1, in that case, what we'll be doing, flatten array means one single array, right? One single array. So what exactly happens? It will narrow down to a matrix, correct? Into a single vector. Whole matrix will be narrowed down to a single vector, correct? Flatten is nothing but a vector. And what does reshape do? Reshaping is nothing but converting a vector into an image form, correct? Convert after reshaping, we'll be doing upsampling. Remember? So initially in the GANs architecture, what we'll be do, we'll consider the latent vector, and on the latent vector, we'll apply a fully connected layer. And after applying the fully connected layer, then we'll consider this. What is this? The reshaping. And after reshaping, we'll do the upsampling. Then we'll get a clear image. Okay. So reshape, right? We're discussing about reshape. What is reshape exactly? Reshape a vector into reshape a vector into image form. That's it. Okay. And what is the next library? Okay, we are done with dense, we are done with flatten, we are done with reshape. Leaky relu, we need to discuss. Okay, leaky relu, what exactly is a leaky relu, we will be discussing. When we are exactly discussing about that particular model building, then I will explain clearly what is leaky relu. Okay, fine. So what is the sequential here? Sequential is nothing but how to stack the layers. Okay, way to stack layers. Okay, sequential means line by line. Okay, so you can write stacking the layers linearly to create the model. Stacking the layers linearly to create the models. Okay, and matplotlib you all know for plotting or for plotting the images. Okay, for plotting images, and also you all know to check the directories and all. Okay, now I hope these libraries are clear, right? Whatever the libraries are present are clear, right? Why exactly each library is over there? Hope everyone understood, right? Even if you're still having a doubt, I'll explain it. Don't worry. These are all the necessary libraries. I won't be running the cell now, but I will be running the cell when each and every cell explanation is done. Okay, fine. So now we are loading and normalizing the data set. Okay, loading and normalizing the data set. So here, what are we doing over here? What are we considering here? So, okay, we are normalizing between -1 to 1 over here. And initially, what is this? X train. And there is this, we are considering only X train. And we don't want to consider the other values which are present in this data set. So we are just defining it as empty over here, correct? Defining it as empty. And how are we loading our data set in the TensorFlow? In the TensorFlow, we are having the Keras modules. And from the Keras module, we have the data set, okay? We are having the data sets. And from the data sets, one of the data set is MNIST. MNIST is nothing but here. In this MNIST, we'll have the data like in a digits format, okay? Digit format. I hope everyone knows MNIST digits format the data will be present. Okay. I hope everyone knows about these digits. Anyone worked on MNIST dataset? MNIST. Or else let me just show you over here. See, this is how the dataset will be. These are handwritten digits. Okay, these are all the handwritten digits, and these are all the labels over here which you are seeing. This is how the dataset will be. Each and everything is an image over here. Okay, on each image, the model will be trained and it will try to remember what kind of image it is. But in GANs, also we are using the same images. Okay, remember the GANs architecture, high dimensional sample space. These are the images of the high dimensional sample space. Okay, these are the high dimensional sample space images. Okay, now we are loading these images inside this dataset only. It is already divided into xtrain, ytrain, xtest, ytest. Okay, so we are just assigning the variables and loading those images. And if you see over here, that is what we are doing. Okay, xtrain, we are only loading the xtrain over here for now. So from the dataset, we have loaded only xtrain and we are not considering the other xtest and the ytrain and ytest. So only xtrain we are loading. And for that xtrain, what are we doing over here? We are normalizing that particular type. See, there is this 127. There is this 127.5 also. What is this 127.5? What are we doing over here? We are just normalizing the pixel values. Okay, what are the pixel we are having? We are just normalizing them, and we are only considering the 175. The batch size is 128 and buffer size is 60,000. Okay. Okay, we are expanding the dimensions to access whatever the axis which is present. Okay, the thing is here we are loading a few images only, but so this whole dataset is having 70,000 images, but here we are loading only 60,000 images, and for each batch size it will be 128. 128 in the sense, in a latent vector there will be 128 latent. In a latent space there will be 128 latent vectors. Correct. Correct. And this one, I'll get back to this line. Okay. After building the generator and the discriminator, I'll get back to this line. So now we are going to build the generator and the discriminator. So what are we doing over here? While building the generator and the discriminator, what are we giving over here? Input shape. What is the input shape that we are giving? 100 dimensions. Okay, fine. The input is random noise vector of the size 100 dimensions, and it is having a dense layer of 256. Okay, and it is a sequential. We are building the model in a sequential manner. Sequential manner is line by line. Stack 1, stack 2, stack 3, 4, 5, 6, 7, 8. Around 8 stacks we are having. Correct. Now, our main doubt is, what is this dense 256? Dense 256 means dense is a fully connected layer. Correct. Dense means a fully connected layer. So the whatever the 100 dimensions which are going as an input will be going through all these 256 fully connected layers. Correct. And after that they will be going into this leaky Rayleigh activation function. What is this leaky Rayleigh activation function? Okay, what is the leaky Rayleigh activation function? Now we will see. Anyone know about leaky Rayleigh activation function? Anyone heard of this activation function? No. Okay, fine. See, leaky ReLU is an activation function, okay, where it will have a small slope for the negative values. Okay? It will have a small slope for negative values. What exactly happens in ReLU? In ReLU, what exactly happens? Let me just share the one more. Let me just stop this screen. Open one more. Share my screen. Able to see, right? Okay. So what exactly happens in ReLU? In ReLU, if the input x value to this activation function is less than 0, then output will be 0. And if that input into this ReLU activation function is greater than 0, then output will be whatever the x value it is. So this is what the exact ReLU function does. So what exactly happens in leaky ReLU is leaky ReLU. Okay. What exactly happens in leaky ReLU now? In leaky ReLU, what happens is here it will have a small slope for negative values. Let me write. Okay. Small slope for negative values. See, in the first case, why did why did the leaky ReLU come into picture? Because the ReLU was unable to handle the negative or the values which are less than 0, correct? The values which are less than 0, the ReLU is unable to handle because it is producing output 0 only, even if it is having some value which is in a negative term. So to handle that, leaky ReLU got into the picture, where it will have a small slope for the negative values. And it is better than ReLU in GANs, okay? Better than ReLU in GANs. Okay, fine. Now I have it out. So, what happens when our output is 0? What happens when our output is 0? The question is to everyone, what happens when the output is 0? No answer. See, if we are getting output at 0, if that output needs to go into a dense layer, then in that case, it will be going through a dense layer, but all the dense layers will be having output at 0 only, because even if you are adding some weight and also some bias, what exactly happens? It will be trained on 0, right? It will be trained on 0. So the model will not understand anything. So in those scenarios, we'll be calling a term, okay? The term is neuron die, okay? Neuron die. What exactly neuron die is? When the input is always negative, so it always gives output at 0, right? And when that happens, gradient will be 0. So it will stop updating, correct? And it will never recover, and it will never recover unless something like external weight initialization or learning rate, which is happening. if you're installing this learning rate, I mean, if you're doing the learning rate, and also we are adjusting the weights, in that case only it may rarely adjust its value. And again, if it is a completely negative value, it may switch to a positive value if you are tweaking all those parameters. If not, it will be remaining in a negative value only. It will be remaining as a negative value only. So neuron die is a concept, like it's a small variable. Like you need to know about this concept. Okay, what exactly is neuron die? Neuron die is nothing but when the input is always negative. Okay, I told you right, for ReLU, when the input is always negative, so it will always give the output as 0. And when every time that output is happening at 0, gradient will also be 0. So it will stop updating, correct? Gradient will also be 0, so it will stop updating. So it results in what? The model will never recover, correct? The model will never work. The model will never work unless we are giving the model weights, or else model initialization, or else updating the learning rate, making it completely slow. Those could be some of the things which we can do in order to make sure that the neuron die is not occurring. But mostly in those kind of scenarios, the neuron die may occur. To avoid those kind of scenario, they have switched from ReLU to leaky ReLU. Okay, that is one scenario. And what exactly is this ReLU? Why using ReLU is bad now? One thing is, when the gradient is 0, it will stop updating, right? So it will reduce the model's capacity to learn in that case, correct? And a large portion might do nothing, correct? Large portion of the dense layers will do nothing. They'll just wasting of this computation power. That's it, correct? Understood what exactly the difference between ReLU and what is that neuron die? Why ReLU is bad? Understood. At least say yes or no, so I can get something and I can move forward. Understanding this leaky ReLU concept is important. There is a cause of dying ReLU also. What is it? What exactly dying ReLU is, and what is the cause of dying ReLU? Okay. And the thing which you are seeing in the notebook, like 0.2, 0.2, 0.2, it is nothing but the negative slope. We are adjusting the slope. Okay, that is the slope we were considering, allowing a small gradient when the input is actually negative. Okay, when the input is about to be negative, we were just adjusting that input by adding this particular slope. Okay, by adding this particular slope. So that is the reason we will be using this leaky ReLU. Okay, fine. I hope leaky ReLU is understood by everyone. If not, let me know. Okay, if not, let me know. And what is the second layer here? Again, we are having a dense layer with 512 neurons with a leaky ReLU concept. Third layer also, we're having the same, and we're having this 1024 layer, right? This is okay, 1, 2, and in the third layer, we're having dense layer of 1024 along with the leaky ReLU again, correct? Leaky ReLU. Then we'll get a dense layer again over here. So output layer, what are we having over here? We're having an activation function 784. 784 means, the dense layer is a fully connected layer. 784 is 28 plus 28. Correct. And activation function tan h means it will ensure that the output is in -1 to 1. Correct. -1 to 1. It will ensure. And reshaping 28 cross 28. So what I'm doing, converting that particular vector from here back to the image format where height will be 28, width will be 28, and channel will be 1. Then we are written in the fully generated model. Okay. We are written in the fully generated model. This is how we are building the generator. Okay, this is how we are building the generator. The input, a latent vector will be passed. It will go through the leaky railroad, dense, fully connected layer, all these things, and finally it will go through activation function and then reshaping. Okay, activation function and then reshaping. So after reshaping, we'll be getting this particular shape, which is having a height, width, and also the channel. And this is how the generator will be working. I hope the working of generator is clear. Let's see the discriminator now. So what is discriminator doing? We are defining a function build discriminator. And what are we doing? Converting the input image into a flat vector, right? Converting the input image into a flat vector. You can see flatten of input shape 28 cross 28 cross 1. So if we are converting this 28 cross 28 cross 1 into a flat, and what happens? It will be 784, correct? It will be 784. And then what we are doing, we are adding the first hidden layer with 512 neurons with leaky railway as an activation function. This is the first hidden layer, correct? And what are we doing next? We are doing a second hidden layer with 256 neurons with the leaky railway again, correct? And at the last, what we are doing over here, we are having an activation function, which is a sigmoid activation function, and we are returning the particular model. Okay, this is how we are building the generator and a discriminator. Okay, how we are building the generator and a discriminator. So here I see we are calling the instances twice, not required. Fine. So what are we doing over here? Calling the above functions, or else let me just comment this. Now what are we doing? We were just calling the above functions to create the generator and a discriminator. Correct. And then what are we having here? After that, we're having the loss function and the optimizers. Okay. Loss function and the optimizers we are having. What is this? We're calculating the cross entropy. T4 Kira's losses binary cross entropy. What is this? And what exactly is the loss function again? What does the loss function do? What does the loss function do? It will measure how close the discriminator output is to true labels. Okay. It will measure how the discriminator output is to the true labels. Let me just write here. Loss function measures how close the discriminator. Okay. Output is to true labels. Okay. Loss function does this. And what are we doing over here? We are setting up the loss functions. Okay. Either it is true labels is nothing but it could be either 1 or 0. Okay. 1 or 0. Fine. So now what is the optimizer we are using over here? Adam. And I hope I have told you about Adam, right? Adam is a combination of both momentum and RMS prop. Okay. Root mean square propagation. RMS is. root mean square propagation. Okay, it's a combination of both momentum and RMS RMS. Okay, and learning that 1 e to power of minus 4 is nothing but the value will be some near like 0.0001. Okay, what is this 0.001? It is nothing but 1 e minus 4. Okay, e to power of 4. So this is what the learning rate means. So the learning rate it is we are considering is 0.0001. Okay, 0.0001. This is the learning rate we are considering for the generator optimizer loss, to calculate the generator optimizer loss. Okay, and similarly we are having this discriminator also, and for that also we are considering the same one. Correct, the same loss item only we are considering. Clear until now? Until now, is it clear? Okay, fine. So then the training setup. Okay, then the training setup. What are we doing over here? Initially we are defining a decorator, right? This is a decorator, right? At the rate is a decorator. Where what are we defining over here? Ti dot function. So we are saying telling a TensorFlow function. It's like a where we are just telling that to compile the function into a TensorFlow graph for performance. Okay, we are just defined it, and here we are having the training step defined as in a function. And what are we doing over here? We are creating a random noise with the shape of batch size, right? What is the batch size we have considered? What is the batch size we have considered? 128, right? With 100 dimensions. 128 with 100 dimensions. And initially we are building a training discriminator or a trained discriminator. So how are we building it? So with gradient tape as a disk tape. What is this gradient tape? To record the operations. Okay, gradient tape will record the operations for the back propagation. Okay, so back propagation gradient tape will record the operations. So we will be having two different tapes. Okay, one tape for the generator and one tape for the discriminator. Okay, we'll have two different tapes. Discriminator tape, generator tape. Okay, we'll also have a generator tape. And what are we doing over here? We are generating the images based on the noise, and then we are extracting the fake image and the real image, and then we are calculating the loss of the real and the fake loss, and combining those two losses we are calculating the total discriminator loss. Correct, total discriminator loss is being calculated. And what are we doing over here? Discriminator tape is present, and from here we are doing the trainable variables we are picking, and also the whole loss we are picking, and we are calculating the discriminator gradient. Okay, we are calculating the discriminator gradient. I hope these lines are clear for you, everyone. Okay, fine. So real and fake, and also the disk loss we're having. Okay, yeah, this is the disk loss. So we are having, and also disk gradient we have. Disk is nothing but a discriminator. Okay. And then the train generator we are having. In the train generator, what are we having? This is a generator tape. We're having a discriminator tape here. For the train generator, again we need to generate the images. Take output, generative loss. Correct. Generative loss, and then the generation gradients, generator optimizer, and then we are getting a generator loss and a discriminator loss. After that, we are generating and saving the images. Okay, what is this? We are saving here generative loss and the discriminator loss, and directory for saving a generated images. We have created a directory to save all those images, and so this is a function to generate and save images. From the predictions, plot the figure, and for a in range of predictions for shape and subplots also we are having. Show the predictions. And what is this 127.5? I told you, right? I will be discussing this 127.5 again. See, 127.5 is nothing but scaling the pixel values, okay? Scaling the pixel values or else shifting the pixel values. And then axis, epochs, saving the figure and executing the training loop. Okay? We'll just run this all these things. Understood everyone? I hope everyone understood. We'll now run that whole notebook, okay? Okay, it's still connecting. Just a minute. Connected now. Just run these cells. Because the cell is already running. Okay, fine. We'll just see. Okay, libraries are loaded. The data is loaded. The generator and the discriminator functions are built. Okay, we have created the instances also. The loss functions have been set up. The training setup has run successfully. The generating and saving functions, whatever the function we have created, it's done. The training loop execution is also initialized perfectly, and now the training is happening for 50 epochs. Correct, 50 epochs it is happening. For the first epoch, you see how the generator loss and discriminator loss is. And epoch, and also you can run the cells from your side also. You can see in each epoch, you'll see the difference. Okay, try to run the cell, everyone. Everyone, please try to run all the cells. Everyone done with the epochs, understood? See, in the first epoch, definitely it is identifying that as a fake image. So it is rejecting, and again a back propagation is happening. So on epoch 2, in the epoch 2, see the generator loss and the discriminator loss. So it's still the same. Epoch 3 is also too much noise. 4 is also heavy noise. 5, there is a noise, but the image is trying to say something, right? And in the sixth is also it's again the same noise. Seventh is same noise. Eighth is also it is noisy. Ninth one is still somewhat noisy. And from if you see clearly, from what epoch are we able to identify the images? Even for 13th epoch, it's the same. 14th epoch is completely different when compared with other epochs. And here in the 15th epoch, we can say this is somewhat looking like zero, right? This one, and this one. So we'll just see. 16, 17, 18 epoch, 19, 20th, 21st, 22nd. Okay, still in the 22nd. So now we can see in the 22nd epoch, this image could be of 9, right? 23rd, 24th. So in the 24th image, most of the images are a bit clear. 25th. So let me just go to 50th epoch. 50th epoch. Sorry. In the 50th epoch, it's 1, 3, and still this image is noisy. We can increase the epochs also. 7, 8, 3, 6, 2, 1, 4. Okay, so see, epoch by epoch, each and every step it has updated its weights and it has generated the image. It has generated the image. And for last epoch, what is the generator and the discriminator loss? Generator loss is 1.6 and discriminator loss is 0.7. Still, it should be low, right? For both, generator loss should be low, right? And also discriminator loss should also be a bit low. So we can either run another 10 more epochs, right? We can either run 10 more epochs also. Okay, you try it from your end. Okay, please add 10 more epochs and you will be seeing a clear images. I hope implementation of GANs is clear. If anyone is having any doubts, you may update in the Q&A. Okay. And in the meantime, if you want to run for extra 10 more epochs, you may run that. You may run for 10 more epochs extra. Okay. And if you're having any doubts of any cell, you may ask me over here. Okay. So in the next 5 minutes, let me know. I'll just keep a poll if you are done with the implementation or not. Okay. I'm stopping my screen now. So run the epochs, implement the notebook, understand the notebook, and then let me know in the poll. Okay. Thank you. Everyone executed the notebook. Anyone facing any issues? Understood GANs now? See, even when you're executing the notebook, also try to think and try to remember how you have understood GANs, okay? How the GANs explanation was. Try to remember the GANs workflow architecture, okay? Then you will understand the notebook implementation also very clearly. Is that clear, guys? And I see only 12 people have implemented the notebook. The notebook have already been shared in the drive, okay? Don't worry, okay? Fine. Okay. Okay, got it. So we'll just have a short break, okay? We'll just have a short break for now. Let's take a 10 minutes of short break, guys. And try to understand the notebook, okay? Thank you. So everyone done with your break and also notebook implementation? Any doubts, anyone? No, right? Clear, right? Everything is clear, right? Fine. So everyone know what is cloud? We'll start with the cloud, okay? We'll start with the IBM Cloud from today, and we'll try to implement few models also. And in between, I will also introduce you people to LangChain, okay? I will introduce you people to LangChain, and one small project we'll do in the LangChain also, where we'll be uploading the PDF, and then we'll be dividing that. We'll be querying about that PDF, or else some kind of such process we'll be doing, okay? With the help of this IBM models only we'll be doing. So we'll just start with the cloud. Just give me a minute. Let me just share the screen and share the PPT also. Just a moment, please. And just confirm me one more thing. Are we done with prompt engineering? Did we complete prompt engineering? Anyone? Did we complete prompt engineering, or else we are yet to discuss prompt engineering? No, right? Yeah, even I'm sure that we haven't completed, but I just want a confirmation. Did I ever mention, or else did I ever brought up the topic? No, no, correct. Okay. So, what do you want me to do? Do you want me to proceed with this IBM Cloud, or else do you want me to discuss the prompt engineering for today and we'll start IBM tomorrow? What do you want me to do? Prompt engineering or IBM Cloud? I mean, Okay, got it. Fine. See, both are important only. It's not like one is a priority and another one we just ignore. We can ignore it. It's not like that. Both things are important only. Let me just check with the slides. Okay, how many slides we're having in what? And based on that, I'll just proceed. Okay. Okay. Fine. Even both are important only. So I'll just proceed with this IBM Cloud. We'll start the IBM Cloud. It will take almost another 2 to 3 days, I guess. Okay, fine. Let me just share this thing. Okay, fine. Let me just enable the. Okay. So first we'll discuss what is cloud, and then we'll start with this foundations, Watson X platform, Watson Orchestrate, Watson Studio. Okay. So what exactly is cloud? What do you people understand by cloud? I see someone mentioned it as storage. Okay. Okay, you people have used this Google Colab, correct? You have used this Google Colab. So what are you doing in Colab exactly? Edge stores it fine. What are you doing in Colab exactly? You were starting a particular server, right? You're starting a server which has been in the existence as a physical server in some location. Okay, getting my point. When you're clicking on connect, what you're doing, you're connecting to a server. Okay, when you're clicking on connect, you're connecting to a server, and what that server is doing, it is creating an online instance where it is providing you with some 32 GB of RAM and some disk space also. And how it is providing? It is providing through cloud. But through cloud, how? Somewhere physically a server with those specification is existing, and by clicking this connect button, the server is starting and up and running. Okay, that is what exactly happening. And what are some applications of cloud? You can say one is storage. Okay, and one example I can say just now is to start our application or run our application, to run our applications. Correct. And what are the other applications? I mean, what are all the other use cases of this cloud? Storage is clear. To run our application, fine. Any other? Okay, fine. Don't see any answers. It's fine. Okay, for now, we'll just keep it that way. To run an application or else to store the files, we can use the cloud. Correct. So in a short format, we can consider as to deploy our application, to scale our application. Correct. To run our application, whatever the infrastructure we need, also we can get all those things through the cloud only. Even while running the same collab file only, the infrastructure is provided by, the platform is provided by the Google, right? The Google. So you just need to have an idea, and you're having all the cloud platforms out there. You just need to go over there and implement your plan. That's it. You can use the infrastructure, you can use the platform. Okay. So what are the types of cloud platforms available, which are very popular? Cloud platforms. They'll provide the platform to us. Okay. They'll provide the platform to us. We just need to use their platform. So what are the platforms available? One is AWS. Okay. One is AWS, and the other one is GCP, Microsoft's Azure. From Oracle also we are having. From IBM also we are having. Okay. From IBM also we are having. Okay. So now in this IBM, okay, in this IBM, what is this IBM Watson X? Okay, what is this Watson X Cloud Foundation, Watson Orchestrate, Watson Studio? We'll see. Okay, in IBM related, what are all these concepts? We'll just see. Okay, so what's the main agenda for this? Introduction to IBM Cloud and Cloud Computing, exploring the Watson platform, getting started with the Watson Orchestrate, and hands-on with IBM Watson Studio. Okay, so cloud computing. So what exactly cloud computing is? It is a model for enabling the ubiquitous, convenient, on-demand network access to a shared pool of configurable computing services. Okay, what are all the configurable computing services that particular pool or else the shared pool has? The networks, related to networks, related to servers, related to storage, related to applications, related to services. Okay, services, and that can be rapidly provided or provisioned and released with a minimal management effort or a service provide interaction based on the niche definition. Okay, so what exactly this is saying? Cloud computing. What is cloud computing? It is, see, cloud computing is nothing but model for enabling the ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. What are all the shared pool of configurable computing resources? See, networks, servers, storage, application, and services. See, we'll just try to think of an example for this. Okay, let's say you were interacting with your friend, and during your interaction, you people just got an idea. You people got an idea. Okay, you people got an idea regarding an application, and you were just thinking to deploy that application right away, run that application right away, and you guys started working on that particular code base and started testing that file. Okay, started testing that file and it is working, and you try to move that file into a UAT phase. Everyone knows UAT phase, right? User acceptance testing. So you try to move into that phase, and you have built an MVP version of it. Suddenly your application is up and running, you got funding and your application is up and running. So now what happens is, when the user traffic is increasing, you need more servers. Correct. When the user traffic is increasing, you need more servers to handle that particular traffic. Correct. So what is that process called as scaling, right? Scaling. So here, if you see what in the configurable computing services, what is that? Servers. One of the example is servers. And what is this servers? Which will help our application to not go down. Correct. And it will help our applications to handle the load also. Okay. You can distribute the load based on the servers. Okay. You can distribute the load also. So that is one good way to use cloud. That is one better option, or it's better way to consider cloud. In cloud we can do auto scaling. Okay, in cloud we can do auto scaling. What exactly auto scaling, we'll discuss further. Okay, in cloud we can go for auto scaling. I'll just say shortly, auto scaling is nothing but we'll set the minimum and the maximum servers number. Okay, minimum server will be setting it as 1 or 2 or 3 as per our daily user traffic. Okay, let's say three servers, and if there is any peak period or a peak time, directly turn on other 2 servers and use those 2 servers also, we'll say. And if there is no peak time, turn off those 2 servers and use only 3 servers, we will be saying. And I mean, we'll be saying in the sense we'll be initializing them. Okay, we'll be initializing them. So that is one kind of auto scaling. So that could be one main advantage, correct? See, let's say as we got this auto scaling concept, let's say there is a big billion sale is happening. Okay, big billion sale is happening. In this big billion sale, everyone are on to your application only. Okay, every person in that particular city are using your application. So you're having only 3 servers, and your computer or else your servers are unable to handle the incoming traffic load. So what you'll be doing, you'll be initializing another server. Okay, you will initialize another server, and that server will also will be considering that particular load, and on all the 4 servers the load will be distributed. The load will be distributed. Even the 4 servers are unable to handle that particular load, you will be initializing the 5th server. Okay, you'll be buying the 5th server and you'll be running it. If you are doing all the things from your own. Okay, let's say you're not going through cloud, you are just having everything on your on premises only. Then what you'll be doing, you'll be making sure that everything you're having your setup, you're buying an extra server, and you're making sure that is being taking the load of the other 3 servers, and the load is being distributed properly. You'll be taking care of all these things, right? So let's just say the load has been increased. Okay, even the 4 servers were not able to handle, and you need to buy the 5th server. Okay, you have ordered all the equipment, but to buy the 5th server, it could take another 2 days. Okay, let's say it could take another 2 days. So now what happens? Whatever the user traffic hitting your website, will be getting an error as a server error. Correct. Will be getting a server error, and they will be redirecting to another application. Correct. They will be going to another application. They will not be visiting your application because you are having a server error. And if you are able to handle that server error, you could have been benefited in your particular application by your application, or else your application could have been good and up and running. Correct. So in order to avoid those kind of scenarios, so that is one way we use servers in cloud. Okay, that is one way we use servers in cloud, and we can also do use it for storage. We can also do use it for running our application, and it will also provide simple services like whenever you go and register in any website, like let's say Udemy, you have registered in that, you'll be getting a mail like, thanks for registering with us, please verify your email. You'll be getting those automated mails, right? So to send those mails, there were many services. Okay, SNS is one service. Like if you're talking in related to AWS, there is a service called SNS. Okay, notification service, we'll call it as. So that is one kind of a service. So it will be having all to handle the application from scratch and scaling that application. All these resources will be available. Okay, all these resources will be available, and it will be provided you through cloud. It will be provided you for you through cloud. So that is the reason it is called as a cloud computing. Okay, I hope I made some sense and you got some idea about cloud computing, and I didn't confuse you, right? I picked up an example also. Cloud computing definition, I didn't confuse you people, right? Understood? Do you want me to keep it simple? Do you want me to keep it simple, or else do you want me to involve the examples also? as I'm not having reactions, I'm unable to understand for which you're saying is. Okay, got it. Fine. So we'll just walk through this once again. I think I made a bit messy over there. Fine. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources like networks, servers, storage, applications, and services that can be rapidly provisioned and released with a minimal management effort or service provider interaction. Okay, all these things, all the server, storage, application, services, networks, they can be provided to us, and even with a minimal cost. Okay, the management with a minimal management effort and also service provider interaction will be available. So that is what exactly cloud computing is. Okay, so what are the key characteristics of this NIST? Okay, so on-demand self-service, provision resources automatically without the human intervention. So when there is any on-demand service which is required, so without any human interaction or else human intervention, the particular on-demand service will be up and running. Okay, and broad network access. What is this broad network access? Capabilities available over the network via standard mechanisms. Whatever the network access which we need to access through cloud, so there will be some standard mechanisms, and what it is saying, capabilities available over the network, whatever the network that we are trying to connect with, there will be some standard mechanisms followed, and it will make sure that it is handling those network access also. Resource pooling. What is this resource pooling? Providers resources pooled to serve multiple consumers. Okay, the providers, who are the providers are like the providers resources pooled to serve multiple consumers, like multiple tenancy, according to location independence. Okay, according to the location independence, the resource pooling will be provided. What is this rapid elasticity? Capabilities can be elastically provisioned and released, scaling rapidly outwards and inwards. See, I told you about scaling, right? So rapidly outward and inward. Okay, increasing that particular server count and decreasing the server count as per your availability. So that is one kind of a rapid elasticity. Okay, what is this measured services? Source usage is monitored, controlled, and reported, providing the transparency. So transparency is a should be one of the first main key character, because if you're using a particular cloud service, you need to know how the cloud service is working, and if you want to set up any budget, you can control it, and if you want to get the monthly stats, you can get the reports. Correct. So those are all the measured service. Okay. So what are the key characteristics? On-demand self-service, broad network access, resource pooling, rapid elasticity, measured service. Okay, these are some of the key characteristics and benefits of cloud computing for enterprises. This is for exactly enterprises. What are the benefits of cloud computing? So one of the best benefit is cost saving, reduced capital expenditure on hardware or infrastructure, pay as you go operational expenditure. Okay, so pay as you go is nothing but let's say you have bought an cloud particular service. Let's say you are involved with a cloud service. Okay, if you have used that particular service for 1 hour, you just need to pay the fee for that particular 1 hour only. So that is what the pay as you go is. Okay, and scalability and elasticity, we have seen this scalability. What exactly scalability benefits are? Elasticity is nothing but easily scale resources up and down based on the demand. Again, the elasticity is nothing but the way we can switch in between. Okay, smoothness, the agility and speed. What it is saying about faster provisioning of the resources, quicker deployment cycles. So whenever we just clicked on connect button in the Google Drive, you have seen, in the Google Colab, you have seen that immediately it was able to connect with the server and the status is shown as connected. So that is what the agility and speed it was talking about. But here it is related to IBM. Okay, here it is related to IBM. I'm just picking up the examples which you have seen already. That's it. Okay, and next we're having this global reach. Deploy the applications closer to users worldwide. Okay, so whatever the applications which you are having, it will be having a global reach also. And disaster recovery and business continuity. This is an important I mean this is an important point. Okay, disaster recovery. So let's say you have deployed your application in one of the location and that location has hit with a tsunami. So in that case, that particular whatever the data which has been stored in that particular location will be gone, right? So in order to make sure that will not be happening, the copies will be kept in different locations. Okay, copies will be kept in different locations. So that is what the disaster recovery and business continuity is, which will help us to leverage the providers infra and for resilience. Okay, it will help us to leverage the providers infrastructure for resilience. So these are the benefits. Okay, cost saving, scalability and elasticity, agility and speed, global reach, disaster recovery and business continuity. And for developers, what will be the benefits? Focus on the code, access to tools and services, collaboration, rapid prototyping. So, what are these benefits again? We'll go through each and every benefit for the developer also, and then we'll understand what are the benefits for these enterprises and these developers. So, focus on the code, abstract away infra and also yeah, abstract away infrastructure management. You just need to focus on the code and don't worry about the infrastructure management. Okay, and access to tools and services. What it is saying, it is nothing but utilize the managed databases, AML services, DevOps tools. All these AML services, the AML services in the sense, machine learning operations like the pipelines, the DevOps tools such as Docker, Jenkins. So you'll be having access to all those services and tools. Okay, so that could be one main point or else one main benefit of the developer. And what is this? Collaboration, rapid prototyping. What is collaboration? Easier collaboration via cloud-based platform. So we can collaborate easily as we are using this cloud-based platform. And what is the platform that we are discussing about? We are discussing about the IBM. Okay, we are discussing about the IBM Cloud Platform. Rapid prototyping. So what is this saying? Quickly spin up the environments for testing. So immediately, if we want to turn on any particular server and we want to check that particular server, we can spin up that environment and we can do the testing. Okay. So these are all the benefits for developers. See, we'll think in a perspective of two people. The person who is managing his own company, the person who is working for working for other company. So first we'll discuss about the person who has his own company. So he will be looking out for the cost saving tips, scalability and elasticity, agility and speed, global reach, disaster recovery and business continuity. So that is what the enterprise level benefits are. Okay, enterprise level benefits are. Okay, and the person who is working for a company, what benefits he'll get, just needs to focus on the code. The infrastructure will be managed. He will be having access to various tools and services. He can also do a collaboration, and there will be rapid prototyping. So understood the benefits for developer and enterprise. Understood until here? What did we discuss? I just discussed about this definition of cloud computing, key characteristics, benefits of cloud computing for enterprises and also for developers. I hope it's clear for everyone until here. Okay, let's proceed forward. Okay. Okay, cloud service models. So, what are all the models we are having over here? See, these are all service models. Okay, and these are very, very important. Even if you're trying to learn AWS or else Azure or else Oracle or else any other cloud platform, you're trying to learn Azure or else be it IBM only. So these service models are very important. The first one is infrastructure as a service, platform as a service, and software as a service. So first, we'll discuss about this infrastructure as a service. Okay, what do you people understand by infrastructure as a service? Infrastructure as a service. What did you understand, guys? Infrastructure. Okay, I'm waiting for some answers. Infrastructure as a service. Are you people aware of this in IaaS and SaaS? If you are aware of it, I'll just proceed like in 5 minutes and I can close it off for today. If not, we need to discuss it in detail. IaaS, infrastructure as a service. See, remember the benefits. Remember the benefits. Benefits for cloud computing for enterprises. What are the benefits here? What are we looking out for? Scalability and elasticity, cost savings, agility and speed, global reach, disaster recovery, business continuity. What are these again? Now just imagine you have built an application. Okay, I'll just give a small example. I won't extend. I'm having a small e-commerce application. Okay, and it is running on only 16 GB of RAM and some disk space, and it is completely running on premises. On premises means nothing but in your own home or else in your own company, in your own startup phase, you're running that particular application. Okay, you're not you have not taken it to cloud. On premises means running on your own premises. Okay, in your on your I mean that application you'll be handling on your own, right? Fine. So I think you got an idea what exactly on premises is. So now when your application is good and running, and whenever there is a huge traffic to your application, you can't buy another server immediately and keep your server add another server, right? You can't configure it immediately, right? Correct. See, let's say your whatever the server, whatever the 16 GB RAM laptop that you're running the application in is unable to handle the incoming traffic, and the users are facing the issues as server error. So what you need to do, you need to make sure that your application is able to handle the particular incoming traffic. So you need to add up another server or increase your RAM. Correct. So what you need to do? So you'll be going online and you'll be buying stuff, or else you'll be going outside and you'll be buying the server. You'll be buying a new server, and again after buying that new server, you need to set up that particular server as per your application, right? So what exactly happens? Whole one day will be gone, right? Let's say that particular traffic is only for half an hour. So what you'll do for that half an hour? You'll just go out and buy yourself a server, and you'll come back and your traffic is completely gone. So what you will do in that case? See this option, scalability. So if you're switching for cloud in those kind of scenario, it will be very helpful for you because immediately it can scale and add another two servers and balance the load. Okay. So that is one kind of benefit of this infrastructure as a service. Okay. In under the infrastructure as a service, we'll get this scalability, cost effectiveness also will get. Okay. Cost savings also will get, flexibility, reliability, security. These are some of the benefits of IaaS. Okay. These are some of the benefits of IaaS. It's nothing but it is nothing but providing the infrastructure. Okay. What are the infrastructure you need? That will be provided. Okay. That will be provided as a service. Like they were providing you the service, but you're running the application in those servers. That's it. So what is the service that you are getting from them? Infrastructure. That's it. Other things you are managing on your own. Okay. And if you want the database to be initialized in the cloud, so what is that? That will be another service. That will be another service. But you're making sure that you're managing your own infrastructure. Correct. I hope you got an idea of this infrastructure as a service. Some of the key features like you can consider scalable storage. Okay. Storage, not exactly storage, scalable storage, networking. We can't provide a high security, right? Yeah, security will be another main component or main feature for infrastructure as a service. Okay. For infrastructure as a service, security, networking, scalable storage, and also you can consider this scalability, cost effectiveness, flexibility. These are some kind of the key main features or components for the infrastructure as a service. Okay. Understood infrastructure as a service? Any examples? Anyone? Clear? Understood exactly what is this infrastructure as a service? IaaS. Infrastructure as a service. And remaining SaaS and PaaS I will discuss tomorrow. SaaS and PaaS I will discuss tomorrow. But let me know, have you understood this IaaS? Don't be blank. At least let me know through the poll, okay? Okay, I see most of you have understood who were listening to the session, and others I don't know. If you are responding, I can at least get to know something. Fine. Okay, so this is it for today, guys. This is it for today. We have implemented that GANs notebook. I'll share an handout also regarding that. And coming into this IBM, I'll share some handouts regarding this also. Don't worry. Thank you. Thank you, guys. Thanks for joining the session. And if you're not having any doubts, you may leave the session for today. Thank you. You guys may leave the session if you're not having any doubts, guys. I see no one is having any doubt. Thank you, guys. Thank you.